In this video, I would like to share about the academic and demographic cluster analysis of engineering student success. Now, I would like to discuss about the overview of our process. The student semester grade point average as a measure of student success to take into account the temporal effects in student success. The findings highlight the student performance based on their demographic status and use of university resources such as financial aid. The higher education institutions are facing retention and graduation problems. One way to improve this is by understanding why students are not academically successful. The main objective of our process is to cluster and classify the student academic performance based on our input data set. The cluster analysis was conducted to understand groups of students based on academic performance and demographic information. The system has developed the clustering algorithm and machine learning algorithm for analyzing the engineering student performance. Now we are going to see about the flow of our process. First dataset, our dataset name is student academic performance. We have to pre-processing the input dataset. In this step we have to handle missing values, label encoding and drop unwanted columns. Pre-processing means we have to remove the unwanted data or unnecessary noise from our input dataset. By using three techniques, we have to perform the pre-processing step. Handling missing values means we have to check any missing values is present in our input dataset. That means we have to remove the wrong prediction. That's why we have to check the missing values. If it is present missing values in our dataset, we have to replace the missing values by zeros or non-values. Then label encoding. Label encoding means we have to encode the data into labels, that is numeric values. Then drop unwanted columns because it is not required for our process. Then we have to move on the module data splitting. Data splitting is the act of partitioning the input data into test and train. In train, most of the data are there. In test, smaller portion of the data will be there. The data splitting is based on classification algorithm. That's why we have to implement data splitting. That data is splitting is based on the ratio. For example, 30% data are present in test, remaining 70% will present in train, or else 20% is present in test, the remaining 80% will be present in train part. Then we have to implement the clustering. Clustering means we have to group the some data. Okay, so we have to initialize the some cluster values. So based on the cluster values, we have to group our data set. In this step, we have to implement k-means clustering. Then we have to implement the classification algorithm. In this module, we have to implement machine learning algorithms. So the machine learning algorithms such as logistic regression and decision tree. With the help of these two algorithms, we have to classify the student performance. Then the performance metrics. Finally the experimental result shows some performance metrics and visualization. Okay, such as the performance metrics such as accuracy. Accuracy is the overall prediction for classification algorithm. The visualization means after you have to grouping the data, so the result will shows that the visualization in the form of graph. So finally we have to get the result. This is the flow of our process. Now we are going to see our demo part, that is our outputs. So just now our programming is running in Spider IDE from Anaconda Navigator platform. After running our process, I will explain the output part one by one. Just our process is on running. Yeah, our process is successfully run. Just I will explain the process one by one. Yeah, so this is the data selection. The data selection means we have to display our some sample data from our input data set. So just I have to display some 10 rows and columns. So totally our data set 10 rows and 42 columns here is displayed. After that we have to implement the pre-processing, right? In the pre-processing we have to check the missing values. Here these are the attribute names, that is column names from our input data. The 0 means there is no missing values in particular attribute name. So there is no missing values in corresponding columns. So here all columns will occur to only 0. So here there is no missing values in our input data set. Then we have to drop unwanted columns. The unwanted columns means unnecessary columns that is not required for our process. So this is the our original data. Actually they contain 44 columns. After we have to drop our columns, that only 28 columns. Then we have to perform label encoding. The label encoding means we have to encode the data into numeric values. Here before label encoding, gender means F and M. For after performing label encoding, it will convert to numeric values. Then data splitting. The data splitting means we have to split the data into test and train, right? The training part only most of our data set, testing part just smaller portion of our data. So this is graph for clustering. Just we have to grouping the performance, academic performance. Then the result for logistic regression. Then this is the result for decision tree algorithm. So this is the output part. Here the variable explorer means we have to use some variables in our process. That variables will be stored in variable explorer. Thank you.